screen share.
All right, everybody. We're going to go ahead and start the presentation. If you have any questions during this, please feel free to enter those questions in the chat, and we will answer those at the end of the presentation. Most of you already have your microphones muted. If you don't, please go ahead and do so as well. Thanks for joining us. My name is Chris Goodrich, Technical Marketing Assistant here at Campbell Company. I'm joined by Travis Goldsby, also Technical Marketing. And Pete Gansey with Control Technologies brought us here together to talk about our new Guardian Wave APS. I guess I will ask just to make sure one more time you guys are all seeing the presentation and you can hear me okay. So feel free to either unmute yourself really quick or let us know in the chat before we proceed. All right. All right. Thank you, Jeffrey and Eric. We will go ahead and go. All right. Let me get where we need to be. Okay, so today we're going to talk about the Guardian Wave APS. This presentation is going to go over several aspects of our new APS device, such as the theory of operation, the detection, safeguards that we put in place, how to identify it in the field, and some testing that we did in-house. Theory of operation. I'm kind of just going to go ahead and read over this. We kind of made this presentation so that way, you know, it could be sent to other individuals. So it's going to be kind of a verbatim thing. Active infrared detection employs an optical sensor and a transmitter. So we are using active infrared for the detection of the touchless sensor on our unit. The signal generated by the transmitter reflects off the surface of a pedestrian's hand, and it's registered by the receiver like the operation of radar. The infrared transmitter modulates a specific digital signal into the carrier signal. When the transmitted light is reflected back, the infrared receiver demodulates the signal, which filters out the carrier and extracts only the digital signal from the transmitter. The demodulated signal is then sent back to the processor. The processor analyzes the demodulated signal to verify that it matches the signal sent by the infrared transmitter.
Yeah, so, you know, what this really is, active infrared, you know, we use it, we all use it every day in our lives, whether you're, you know, going into the bathroom and waving your hand in front of the paper towel dispenser, and things like that, you know, remote controls for televisions, they use active infrared. So this isn't any sort of new technology or anything like that. It's an existing technology that we're just utilizing to allow for that no contact actuation.
So here we just have a little quick diagram showing the face and the top side view and side view of the Guardian APS, the Guardian Wave. It shows the placement of the sensor that's directly underneath the actual actuator itself. So the sensor is located right here. Physical push button is located right here. And this top diagram just kind of shows the infrared coming out of the sensor or out of the emitter, hitting the hand, coming back, and being received by the receiver. Excuse me. Detection. The wave sensor detects the presence of a pedestrian's hand between 1 to 3 inches away from the sensor. We actually have been tweaking this a little bit after some extensive testing down with Santa Clara County in California. They were the first ones to reach out to us, and we'll go over that a little bit later. But it is now adjustable. Initially, we made it 1 to 3 inches to make it have the pedestrian show intent that they were actually wanting to cross, and it wasn't just going to be set off by a pedestrian just walking by with no intention to cross the street. So initially a 200 millisecond pause was required to detect intent, but feedback suggested that allowing a range sensitivity range and sensitivity adjustments. So we went ahead and put in those adjustments in our PegConneX utility. So you are able to do a couple of adjustments on there for the sensor. We do highly recommend, as of right now, that if you do have these deployed in the field, to please call our tech support to help you with the settings changes. But right now you are capable of changing the sensitivity as well as some of the other settings on there that allow for the range. Detection safeguards. The system has 3 layers of protection to ensure that it is receiving an accurate call. The infrared receiver has a narrowband response, ignoring any light that does not have the correct infrared wavelength. The infrared receiver ignores all light that is not pulsing at the correct carrier frequency. So this includes the infrared light at the correct wavelength. So even if that wavelength that's coming in was the correct wavelength, if it's not pulsing at that exact frequency that's looking for, it's going to go ahead and ignore it. And the firmware only interprets a valid call if the demodulated signal from the infrared receiver matches the signal modulated by the infrared transmitter. So the first 2 layers of those protection safeguards, they safeguard against noise due to ambient light, headlights, street lighting conditions, shadows, that sort of thing. And then the final layer safeguards against objects like I mentioned earlier, a TV remote that use the same fundamental technology, as well as electrical noise that may enter the system between the infrared receiver and the processor. And the final protection layer is built into the firmware algorithm that processes the received pulses. Constant call safeguards. The Guardian Wave has a built-in safeguard to protect it from being placed in a constant call. Once a hand has been placed in front of the sensor and the sensor has identified the intent to place a call, the Wave will play a wait message. Right now, MUTCD or most of our orders do go out as a 1-second extended press. So either the physical push button or now our Wave sensor will detect 1 second before it plays the extended press message. That can't be changed. But again, now with this Wave sensor, it can be done with either the physical push button or the Wave sensor itself. You can just put your hand in front of the sensor for a little over 1 second or a little bit over, depending on what the settings are set to. And it will play the extended press message and tell the pedestrian, what street they're crossing at what location. If a user leaves their hand in front and the sensor beyond the extended press, and the sensor will not continue to place a call. So we want to make sure that that wasn't just going to continuously call. The physical push button has a safeguard to protect from a constant call, and if it is stuck in the push position, it will stop placing a call after 8 seconds. So that way, we're just not messing up traffic all the time. Identification and indication of the no contact actuation. The Wave technology is identified by a large contrasting Wave logo. The Wave logo is easily recognizable, a hand symbol to indicate the touchless actuation technology. Like Travis mentioned earlier, if you've gone to a public restroom, you've seen the touchless paper towel dispensers. Those typically have a Wave logo on them to indicate that they are touchless technology. Wave technology is also identified by a unique locator tone in the APS device for visually impaired pedestrians. So that's, of course, one thing that has been brought up many times before, speaking with customers, contractors, DOTs, is that, well, how is a visually impaired pedestrian going to know that they can just wave their hand once they actually hear the locator tone of an APS device? So we've actually created a new locator tone. It kind of has like a double beep to it. We're really hoping to be able to send that out and send that information out to agencies so that way they can, make people aware of this. And we are going to be producing an informative package to share with advocacy groups.
We actually had a really good meeting with a commission for the blind and visually impaired here in Boise, Idaho yesterday. And we actually discussed with them, some of the things that we need to address to properly help the visually impaired. And, some of the things was just, once we send this out, it's just going to be, the thing that we can do to most help the visually impaired understand the no contact actuation is just to inform, these nonprofits and these groups that work with them where these APS devices are being installed, because, just like us, a visually impaired pedestrian is usually going to take the same routes, whether they're going to work or whether they're going to the store. And so by just informing the public where these new devices are going, then you can really do a lot to help them out. And we are starting to do some testing with visually impaired pedestrians here in Boise. And like we said, we will be putting together that informative package to share with the agency, so you guys can therefore share it with these advocacy groups.
Okay, compliance. The wave sensor is designed to comply with all standards that are relevant to normal APS push buttons, and that includes MUTCD, the ADA, US Access Board, and TAC. We wanted to make sure that, the device was still compliant, obviously. It still has a physical push button available, and the sensor itself does meet the standards required for MUTCD for a passive detection. Installation. This is definitely one of the questions that we've been asked the most by contractors and DOTs when we first announced that we were creating a touchless APS device was, well, what do we have to install now? And we're very happy to say that with our independent APS device, the Guardian, the installation is exactly the same as it is with our current Guardian. There's no differences. There's nothing new to put into the cabinet. There's nothing new that you need to put at the pole. If you are familiar with our Guardian APS device and have installed it before, it is installed exactly the same with the Guardian Wave. There's no differences. There's 2 wires that come from the cabinet for the pedestrian call, go to the pole. They are terminated here at the 2 terminal blocks for the field terms. And then there's the 4 terminals for power, as well as walk and don't walk. That goes up to the signal ped head and works off of our SPI device that uses the power from the 120 volts from the signal head. So no changes made there. We have a couple evaluation sites up. We have a few here in Boise. We work very closely with our Ada County Highway District. They're always happy to take samples and evaluation units and test them out and beat them up for us. So we have 2 intersections set up. We have a crossing right in front of their office in Boise, as well as an intersection just around the corner here from our facilities. We have one in Beverly Hills, Stamford, Connecticut. We've been working closely with Caltrans and Santa Clara County. There's also evaluations for the Caltrans METS lab in Sacramento. RRFB. So the current Guardian, our standard Guardian has always been a very, or is a good option for RRFB crossings. It is a low power consuming device. And the Guardian Wave is really no different. The Guardian has one of the lowest power consumption ratings, makes it ideal for RFB. It works great with solar powered RFBs. Works great with hot crossings. The 5.0, which is what our current Guardian is being called, is compatible with nearly every RFB manufacturer. We've also sent out samples to the RFB manufacturers that we currently work with, such as Trafficom. They tested the Guardian Wave with their push-to-cross system, and it works great, as well as Carmana. And then, as with our previous Guardian version, the Guardian Wave does come with a Bluetooth option. So the Bluetooth module add-on allows you to have wireless connectivity to the unit itself for configuration purposes. And that works great with our PetConnex app. All of our Guardian units still include USB connectivity as well. We did not remove that at all. So all of our APS units will always have a dedicated USB port, but Bluetooth is an add-on option. Okay, we're gonna go ahead and go over some testing now. And I'm gonna go ahead and let Travis take over from here.
Yeah, so, we came up with the Guardian Wave because we had an agency in California, once COVID started happening, contact us asking if we had a, no contact APS device so that we can help stop and slow the spread of COVID and other germs and viruses even after we finally get over COVID. And so this testing data was actually all done when we were all working from home when COVID initially hit. And so you're going to see in a lot of these videos and images that they look like they were done in someone's home. And that was the case. They were, our engineer took some devices home with him and he ran all these tests there. So yeah, they, don't look like your standard testing videos. That is why. But so one of the first tests that we did was we wanted to see if the two sensors would interfere with each other when placed at 90-degree angles towards one another. Now, I highly doubt we're going to see two devices this close together. But, we have seen some very odd intersections in our times of working. And so, just to make sure there wasn't any interference, we wanted to see if one station would set off the other or if it would stop one station from placing a constant call. And so here on this video, you can see that first sensor, the one on the right, is labeled number 4. When the hand was placed in front of it, you heard the number 4. And then when the hand was placed in front of the sensor on the left, that's device number 1, we heard a 1. So we didn't hear them going off at the wrong times. We didn't hear them setting one another off. And, so that was ideal. The second test, we wanted to see when exposed to continuous sources of infrared radiation, would the sensor generate false actuations? And so what we did here was we placed the station in front of an infrared heater, and we wanted to see if it would cause any constant call, cause any no calls to be placed, any false calls to be placed, and we did not see any of those things happen. So, we're surrounded by infrared in daily life, whether it's infrared from the sun or infrared from other objects. And yeah, we have not seen any sort of problems with that. So here on our third test, we exposed the Guardian Wave to pulse sources of infrared radiation. As we spoke about earlier, TV remotes, they use active infrared to change the channel, turn the television on and off. And so what you're going to see in this nice video is our engineer is pressing buttons on the remote, trying to get the sensor to place a false call or to go into constant call. And it's not until you see him wave his hand in front of the device that the call is actually placed. So.
Wait.
And so neither before he waved his hand in front of the sensor nor after did it cause a call to be placed or cause any sort of constant call. So, that is exactly what we wanted. We definitely did not want somebody to be driving by with a TV remote for whatever reason they might have one on them, to try and use that advantageously to speed up their stoplight. So.
Wait.
Okay, so we also tested to see if when the sensor is exposed to car headlights, if the sensor would generate a false actuation or failed actuate. A lot of the newer vehicles out there, they are using headlights that do actually move into that infrared wavelength, such as the xenon and the mercury xenon style headlights. And so, we wanted to make sure that it wouldn't place a false call or cause any constant calls or interrupt trying to place a call. And so, as you can see there, we shine different lights at the device, and we never saw the device having any calls made when they weren't supposed to, nor did we see it impede the ability to place a call. So here, this is actually a question that we have been getting a lot of, and it's if the sensor is covered, will that impede the device's impact to place a call? And so what we did was we used various types of tapes and stickers to see if calls would be placed. And so we used Scotch tape, we used painter's tape, we used stickers, we used electrical tape. And what we noticed was that for the most part, none of these tapes impeded the ability to place a call. Now, some of the thicker tapes might have made it so you had to be a little bit closer to the device, but really, unless you see, unless someone decides to come up and maybe, spray paint just all over it and put layers of spray paint on it or stick bubble gum all over the sensors, then yeah, it would impede the ability to place a non-contact call. But in those cases, you do still have your physical push button, so you still can use that. Um, you can always, if there is gum or if there is spray paint, you can remove that gum and spray paint. And if you accidentally scratch up those lenses covering the emitter and the sensor, then you don't have to worry about it. We initially, when we created this device, we put our Wave logo on the over top of the sensor, and so we actually etched it into to those windows, and it did not impede the ability to place a call or the distance needed to place that call, that 1 to 3 inches. So if you're worried about scraping off paint or scraping off gum and scratching up those windows, you don't actually have to worry about that because the sensor would still work fine through those scratches that might occur. So one thing we wanted to do, we wanted to expose the Guardian Wave to extreme temperatures. We have a thermotron here at our plant, and what we did was we checked the stations at negative 40 degrees Celsius all the way up to plus 80 degrees Celsius. So went from extremely cold, and I forget what negative 40 Celsius is in Fahrenheit, but all the way up to 80 Celsius is, I believe, 176 Fahrenheit. And, you're really most likely not going to, hopefully not see those types of extreme temperatures anywhere. But, we have tested it to make sure that it would work in the most extremes possible. And while doing that, we saw no effect to, the strength of the sensor, nor for the ability to place a call or, have false calls placed. It didn't cause any major, any problems with the board or with the motor or anything like that as well. So.
This slide doesn't show the information for it, but it also ties into the physical push button as well. This is the same testing, the temperature cycling that we've done for all of our devices. And we found no differences with the sensor being placed in there or the physical push button actually being activated as well. So we just wanted to make sure, even though the previous Guardian or our Guardian 5.0 has gone through those rigors before, we just want to make sure that adding the sensor did not make any impact on that.
So here's one that I'm guessing, down south, you guys really aren't going to have to worry about too often, but does a layer of ice covering the station trigger unwanted actuations? And can the sensor detect a hand through a layer of ice? So I'll play this video real quick. As you can see there, what we did was we put the device in our thermotron, brought it down to that negative 40 degrees Celsius, put water over it, and it's a little hard to see in that video, but there is a layer of ice over top of the sensor, and it did not impact the ability to place a call, nor did it cause any false calls to be made, or it didn't affect the the push button either. With our new with the new way we have our Guardians developed, our push button is flush with the device rather than sticking out, which also helps that. And if for some reason maybe that push button does get stuck in with ice or something like that, it does have that after 8 seconds, it'll no longer place a constant call. And now you have the sensor. So for some reason that physical push button isn't working because of ice or something comparable, then you do have that other means to place a call. Okay, so the next test was, does water running down the face of the sensor trigger unwanted actuations, and can the sensor detect a hand through running water? So, this is something that, you guys down south are going to have to worry about a lot. You guys definitely have a lot of water and a lot of rain that happens all the time. So we wanted to make sure that water running over top of the sensor didn't place a false call, didn't cause constant call or anything of that nature. So. So as you can see, what we did was obviously we put the device in a plastic bag because we had live wires and everything, and our engineer did not feel like getting electrocuted that day. So we had that water running pretty strong over top of the sensor. It didn't cause any false calls to be made. And even through that layer of water, our engineer was still able to place a call. Okay, so this is our last slide here, and what this details is when exposed to various environments found in most metropolitan areas, will the device trigger false actuations or fail to actuate? So what our engineer did was he took the Guardian Wave device and he brought a battery with him, and he drove around all over the Boise area, and he drove through busy downtown intersections, drove next to our airport. He drove out next to the National Guard base. He went by large power transformers, areas with a lot of shade, areas with a lot of sun, kind of just anything that you could think of, he drove past and tested it. And no matter where we took the Guardian Wave, we did not find any false calls being made. We did not find any inability to place a call. We did not find anything that would make a constant call happen. So we're very proud to see that, and really happy that there's no environmental factors that really affected the ability to place the call. One thing we did find out is that in areas of a lot of sunlight and direct sunlight on the device, one thing that it did do was it did extend the range in which a pedestrian could place a call. And so rather than being 1 to 3 inches, sometimes they extended it out to 5 or 6 inches. But as Chris discussed earlier, we now have that ability for you to adjust the sensitivity of the sensor. So, if you're in a spot where your Guardian is going to be in constant sunlight for most hours of the day, you don't really have any trees or shade or anything to put shade on the device, then maybe it would be good to turn that sensitivity down a little bit so that you aren't having calls being placed 7 or 6 inches away from the device. You might turn that sensitivity down so it does bring it back to that 3-inch range. And if you do remember that image from PedConnects showing the sensitivity and stuff, there is a day and night mode. So, you can adjust the sensitivity for, night and day. But as we said, we really strongly encourage you to contact our technical support team if you are going to be making any of those changes, so they can give you, guidance as to how much to change the sensitivity and things of that nature. So, and that is what we have for the slideshow. But what we will go ahead and do now is we have a Guardian device set up here in our conference room, and we will kind of just give you a little bit of a live view of it and how it works and all of that.
Can I ask a couple of questions?
Yeah, why not?
Absolutely.
I want to know how you do it. I work for the city of Tampa. I'm a tech too. One, I wanted to find out, I noticed when you activated the device, it said wait. Is there also another voice that when it clears to let visually impaired know they can cross?
Oh, of course. Yeah, so this device is acting just like a standard APS device. It will say, the initial press will say wait, an extended press will say wait to cross, or if there is a custom message that's been requested, it'll say, wait to cross Main Street at Front Street. And then once the walk cycle goes up, the ped head and the Walkman go up, it will say walk sign is on to cross.
Okay, now second, I noticed you say there's no real big wiring differences than normal, but I also noticed there's 6 terminals in the button. What are those for?
Correct. So the 6 terminals actually here, let's go back.
Only because when you showed the wiring diagram, it looked like the ped head gets wired to the button, so it runs through the button to go up to the head.
Correct. So
Yeah.
So what I'm worried about is, just quick question, where you showed when you ran it underwater, you had a plastic bag over that, but
yes.
We live in Florida and we get torrential rain, and now you're talking about if you're running the ped head through there, now you have 120 running through that button. Now, if water gets in that button and someone comes to put their hand over there, is there a possibility of them getting shocked, electrocuted?
Right. So good question. So you're looking at our slide right now?
I am not, but I can slide over to it, which is fine.
Okay. All right. So just a quick explanation of that. So when somebody orders our Guardian APS device, what comes with that package is the actual push button itself and likely a sign, depending on what size they need. And then what also comes with that is its own individual power supply. So what this power supply does is the 120 volts comes in from the signal ped head, and that's converted down to 12 volts DC. So the Guardian is only using 12 volts DC from that signal power head.
And so you run that from that signal power interface, which you install up in the ped head. And we strongly encourage you install it on the back of it, not on the bottom part of the ped head, so that it's never sitting in water. And then you have those 4 wires running from that signal power interface down to the Guardian. And when you were talking about, when we ran water over it, we had it in a plastic bag, but that's because, right?
Guys, we're all seeing the screen.
You can't see the screen? Oh, shoot.
Oh, probably would help to share the screen again. You have to go back the other way.
Sorry,
How's that?
there we go. Okay. Sorry about that. So yeah, here's that SPI. Here's a ped head that we were just talking about that slaves off the 120 volt and then powers it down to the 12 volt DC. But so we had a plastic bag over top of the Guardian because as you can see here, this door that's covering these wires is taken off in this diagram. And we're actually going to show you here in a second a video of us showing you the Guardian Wave. And
Right.
you'll see that the door is on it and that door is waterproof. So water will not be getting into those wires there. But because for the testing purposes, we didn't have the door on it or anything, we just had those wires live. We had a plastic bag over it.
Yeah.
But
But
mainly, you don't have any of the major like controls or anything in the cabinet. Everything is pretty much in the bed head and down to the button.
Correct. Yep. The only thing that the Guardian is wired up to in the cabinet are just the field wires to place the ped call.
Okay.
and so yeah, we will go ahead and show you. Let's switch to some. How do I get over there?
That way.
All right, we're gonna start a video for you. Pause this share. Now, can you guys see our video? With Shelby standing right here in front of the Guardian Wave.
Okay. Are you guys seeing the video, the Guardian Wave and Travis standing there?
Yes.
Okay. Excellent.
So yeah, as you can see here, in that video, so right here, this is that door that's covering where those 4 wires, well, I guess 6 wires and 2 field terminals and the 4 wires getting routed up to the SPI and the ped head. This door is covering it, so we don't have those wires exposed. It is waterproof, so you don't have to worry about someone getting electrocuted. Turn this on. So right now we don't have a sign on it. Reason behind that is we wanted to showcase one nice thing about all of our Guardians. Chris, could you pull that camera a little bit closer so we can show this off a little bit better? But what we have here is we have areas where the sound is emitted from the device. So what we have on that is on this side we have some sound baffles to stop the sound coming out. So if you want to do some directionality with your sound and things like that, you can. But we have our actual physical push button right here with the tactile arrow, and it still has a vibro tactile response to it for those visually impaired pedestrians. Here are our sensors for the Wave, and so I'll just show you real quick. Wave of a hand, your LED, your latching LED comes on, and you wave it. If you want to do the extended press like you asked about earlier, I can you the wait
to cross.
Followed by a wait to cross, just like the same as the button. So
Wait to cross.
Can I ask, are the arrows directional? Do you have to buy specific right and left buttons, or can you actually rotate the arrow?
Yep. So the actuator on there, I don't know if you can see it, but the center of the button has a torque screw. So that torque screw can be unscrewed, and you can turn the direction up, down, left, or right.
yeah, so you don't have to have it. Let's say for some reason you decide you're either going to move the device to a different pole, or you're going to, maybe the intersection just changes for some reason, and you want to change that arrow, you can. One nice thing though, about this is, so when you place an order, you can place it and you can fill out what we call an intersection planning form. And so therefore, if you want some custom audio, like Chris was saying, wait to cross Front Street and Main, and then walk sign is on, cross Front Street, you can do that. We can produce those custom audio messages for you. We don't charge any extra for those custom audios to be made. So, that is really helpful. And what you can do through our Ped Connect software, let's say you decide at a later date you want to, add those custom audio messages. You can either have us produce those for you, or through Audacity or other softwares that you can create MP3 messages with. You could create your own MP3 message. And or wave message, excuse me, not MP3, wave, so .wav. You can create a special wave message to, put in here for your audio and for that. But, so yeah, it has a locator tone still. What's going on? Oh,
Better you can walk.
okay. So yeah, we still have the wait. You saw the wait.
Wait.
Button works.
Wait to cross.
And I'll show you, I'll kind of turn it sideways a little bit so you can see.
Wait.
I'm about 3
Wait.
inches away right
Wait.
there. If I'm further away, we get no call being placed. I can come in
Wait.
at it, and,
Wait.
side to side,
Wait.
forward. I can use a sweater, and that works. Really, it works for almost all fabrics and all types of materials. There are a few different like black plastics that the device doesn't pick up very well, such as like the inside of a snow glove that kind of has that black grippy polyurethane. That doesn't necessarily work, but if you're wearing a sweater or something like that, you can wave that in front and that still works. So, it really works for most things.
Yeah, if you're wearing the one thing, we tested with a lot of winter gloves. Sometimes the poison winters can be pretty harsh. People were walking around with, heavy gloves, ski gloves, that sort of thing. So there are some of those dark materials that did not reflect the infrared back. But at that point, we kind of figured, well, this device was really quickly made for in response to COVID. But if you're wearing a glove, you're probably pretty safe to go ahead and press that physical push button.
I got a notebook here. Here's the papers. Let's say it's a busy intersection next to a law office or a courthouse or a hospital or something. You're carrying a stack of papers.
Yeah.
That works too.
Actually, one of the feedback that we got from Santa Clara County was that the installation site that they put their eval units at was a hospital, and that's when they told us, hey, you guys need to make this a lot more sensitive because there are people that are walking by that don't even have a free hand. So we wanted to make sure that they could literally walk by, have their hands full, wave their elbow at it, and still be able to place a call.
All right, so what we're gonna do now is open up the chat. Let's go ahead and answer some of these questions. So, we got a few people asking if we can send the PowerPoint presentation out, and yes, we can. We will have, we'll be giving Pete a copy of it as well as a copy of this presentation in entirety. I'm sure he'd be more than happy to send it out. Let's see. Is it functional by wave and button at the same time? Do you also have audible ones? So yeah, if someone wants to, if someone came up and waved at it and then the next person came up and pressed the button, it doesn't affect it. It still registers both calls.
Mm-hmm.
You could have someone, one day people might decide to only use a button. The next day they might decide to only wave their hand. It's not going to affect the device at all. It's going to either option someone wants to use, if they want to press a button or if they want to use the sensor, it is available.
Yeah, and just to answer that second question, yes, it is an audible device. It is a fully functioning APS device. So as you saw and heard, locator tone, wait message, extended location message, as well as a walk message.
And as we said, you can do those custom audio messages, and you can just, when you place the order, you can fill out a quick form that you can identify to us what the intersection is it's going in, what the streets are, what the phase it's going to be in, and then we can curate those custom audio messages, and those are free of charge. There's no additional cost for those custom audio messages. Okay, we got some black screens. Yep, that's
Sorry about that.
It says, you mentioned there is an application available for an agency that changes sensitivity settings. Can you elaborate on this, please?
Sure
So,
can.
yeah, so what we use on all of our Guardian devices, and
Go ahead and share. I can go ahead and share this.
so what we will do,
Go to new share. Go to phone or iPad. Click share.
Oh.
Boo. I wasn't like that last time.
Yep.
Okay.
Why don't you just put it in front of the camera? Yeah. So there's a couple different ways to access we don't have any torques in here. Well, there's a couple different ways to access the software that is used. One is through phones, as you can see there, Chris's phone. That is the PedConnect software that is used on mobile devices. And what Chris is able to do is, if you have the Bluetooth being used, then you can use an iPhone, an iPad, a Samsung device, anything that has Bluetooth connectivity, and connect to the device through Bluetooth. Or we do have USB that you can use to connect a laptop to it as well. Or if you're working on it in your office, you can connect your desktop to it. But what the PedConnect software does is it allows you to, change audio messages. It allows you to change sensitivity. You can change, the day and night levels of audio. So let's say
I'm going to go ahead and show you really quick. So this is showing a list of available devices that I can connect to. So we obviously have a few APS devices with Bluetooth connectivity here available to us. There's a couple that are just over in engineering that are active. The one that we're demonstrating right here is the one called Guardian Wave with NFC. So I already have the password saved to it. It is password protected for each station. We do give you the password when a Bluetooth APS unit is ordered. So only the end customer has the Bluetooth or the password access. And then you can also save that password to your device. That way you don't have to keep doing it every single time. So now I've already logged into this Guardian Wave, and then I have options. I can do configuration. I can change audio. So I'm going to show you configuration. So this gives you abilities such as changing the APS mode. So you can change it from ME2CD to RRFB. You can turn it off. You can turn it into test mode. You can change settings such as the extended press time, the locator period tone. So instead of once every second, it's beeping once every 5 seconds. Vibration intensity, recall, that sort of thing.
I'm going to switch to screen share real quick.
Sure.
All right, so here I just pulled up. This is what the PedConnect utility looks like on a laptop or on a PC. Right here we have multiple different options to use. You have different modes. Oh my gosh, sorry. There you go. This is a PedConnect utility through either a PC or a laptop. You can adjust audio. We can hook up different audio tones to it for different locator acknowledgement, extended press. You can switch between MUTCD mode, RRFB mode, beacon, things of that nature. We have volume, so you can adjust how loud the speaker is. You can adjust how quickly the device goes up in audio. You can adjust different audio for day and night mode. So in night mode, you would have audio playing. You can set it so it goes up to a certain decibel rating during the day, and then let's say at night it's on a corner that's next to a person's house who doesn't want to hear the beeping all night. Then you can turn the audio down and turn the speaker to a lower volume during the night.
Go to advanced.
Here in advanced, if I scroll down here,
The sensor setting. Yeah.
here's that sensor setting that we were speaking about earlier. You'll see with sensitivity, you have an ability to change that sensitivity from fast to slow. If it's fast, that means a quick wave of the hand in front of the sensor will pick up the intent to place a call. If you move it to slow, you might need a little bit of a pause almost before that is picked up. It's not a full pause, not even that 200 milliseconds, which we initially thought would be beneficial. It's just you can't wave your hand as fast as you can in front of it.
And just to touch back on the these applications, so both the PC-based application for PedConnect to change these settings, as well as our Bluetooth app, those are both free. The PC-based one is available on our website. We have a link to download that. And then the Bluetooth PedConnects that you can use for your iOS or Android devices, those are both available on the Apple App Store as well as the Google Play Store for free.
All right, so let's see, there's a question. Have you ever installed it in a diagonal crosswalk? What benefits can we give to the impaired people with these devices?
Now, diagonal crosswalk. Claudia, I don't know if you want to unmute yourself so you can kind of elaborate on this. I'm kind of assuming this is like maybe for a scramble.
Good morning.
Good morning.
Can you hear me?
Yes.
Yeah. Oh, okay, perfect. No, it's for a mid-block crossing.
Okay.
And yes, they were like trying to like see if like these devices can have like any benefits for the impaired people. So yeah, I just want to ask you guys if you ever had this situation before.
So for like a mid-block crossing, are we talking like an RRFB?
Or a hawk maybe?
It has like a small aisle like in the middle of the road, and it's a diagonal crossing for pedestrians to go from one side of the road to the other.
Yeah, so actually here in Boise, we do have one of those set up in front of the Ada County Highway District, and Ada County is the county that Boise resides in. And so in front of the Ada County Highway District's offices, we do have a mid-block crossing there that we use. And yeah, we haven't had any problems with it. It's actually a hot crossing, but yeah, it's in between two intersections, so it's not at an actual intersection, but it does help pedestrians across the road, because the next closest, if we didn't have that there, it'd be quite a long route before someone had an actual intersection to cross. But yeah, so it does have that lower power consumption. So whether it's solar powered mid-block crossing or anything like that, it does work very well with it. Right. And as for the impaired pedestrians, so depending on the type of impairment, a visually impaired pedestrian, what it does for them is the same thing it does to us. It allows for a pedestrian to be exposed to less germs and viruses by not having to press the same physical push button that everyone else presses. Another benefit of this is, let's say there's a pedestrian who, maybe they have cerebral palsy or they have MS or something, and they don't necessarily have the full function of their limbs. And so it might be very hard for them to actually press the physical push button itself. Now you have a sensor, so they don't actually have to worry about, getting their hand on the button and pressing it and putting, the pressure onto the button to actually make it work.
Okay. To get back to your question though, so sorry, I think we might have misread that a little bit. Curb ramp directs people perpendicular, but the crosswalk itself is diagonal. Okay, so this was actually something that even our previous Guardian version was actually able to help with. You're talking kind of about directionality, making sure that the pedestrian is actually able to cross in the correct direction. What our Guardian APS device is capable of doing is there's a setting called beaconing mode, and what that does is once a button is pressed on one side of the street, once the walk phase goes up, the push button on the other side of the street will actually emit a tone So a visually impaired pedestrian can hear that tone and know which direction they're supposed to be walking in. Of course, you know, our arrow direction on the push button itself is still present. It's still a tactile arrow. So they can also feel the direction they're supposed to be crossing. Of course, with this device, our intent was that they wouldn't have to, you know, press the button or feel for arrow direction. But, you know, unfortunately, you know, we as much as we wanted to make everybody safe and not have to touch the push button with this iteration of the Guardian, we do realize that there's still going to be a large majority of visually impaired people that will rely on, you know, physical touch to make sure that they are moving in the correct direction. So the physical arrow is still present, but you can also use that in tandem with our beaconing capabilities to make sure that they are moving in the correct direction.
Yes, exactly. I was also talking about that tone that you listen on the other side of the street.
Right.
And in this case, the arrow will not work so well because it's gonna be diagonal. So you can just show, like, they can just touch it and they can go like perpendicular, but not like diagonal. So yeah, the arrow will not be so helpful in this case either.
Well, that would depend on which direction the push button itself is being angled to. Is the push button on a pole that's being angled perpendicularly to the street, or is it being angled towards the direction they're supposed to be crossing? Because obviously that would be pretty dangerous. And we would hope that, you know, if there's another push button on the other side of the street from where they're leaving the curb, that it's also placed in an area that, you know, they need to be directed towards.
But, you know, we have a lot of different adapters and different features. So
angle mounts.
Yeah, different angle mounts. So you can, you know, let's say with the way the pole and the intersection is set up, maybe the pole isn't at the ideal location to point the button towards where the ramp is at the curb. We do have different angle mounting kits and different extensions and ways that you can, without having to do any major construction to the pole or anything, you can turn that Guardian device towards the proper, towards the curb and try to have it line up better with where the ramp is.
Okay, remember that the curb is going to be perpendicular.
Yep. And
So anyways, the people will try to cross and they will think the crosswalk will still go perpendicular. But once they hit the pavement, then the crosswalk is the one that goes diagonal.
So at that point, you know, that kind of sounds like there might be an issue that, you know, it might not be compliant with the direction of the street. I'm not really sure.
Probably the beaconing would be your best bet there.
Yeah.
We also have speakers and beacons that you can place on, you know, where the other side of the crosswalk is. So therefore, you know, you can, there's a handful of different ways that you should hopefully be able, whether beaconing or using speakers, to direct that visually impaired pedestrian to the other side of the crosswalk.
Right. But yeah, so our APS devices can, you know, help give directionality to an extent. But when it comes to something like that, where the curb isn't even in the same direction, you know, the grade is not in the same direction as the crossing direction, that's a little bit out of our realm. We do have, you know, our beaconing device. The Guardian itself can act as a beaconing device. We can, you know, we can help pitch the sound into the intersection so that way it's easier to hear when you're already in motion to cross. But you know, those are only
exactly something like that.
And so far, I mean, yeah, at that point, that might be something that needs to be addressed to the city, that, you know, the curb needs to meet the same direction as the crossing, or it needs to be adjusted. The grade needs to be adjusted so that way it's you know, safe for all pedestrians.
Yeah, but yeah, we have like speakers that you could put on, that you could put underneath the ped head, or that you could put at different locations on a pole, and do throw that sound towards your intended area to try and help people out. So, you know, if you, let's say you do want to like purchase a Guardian for that reason, you know, either contact Peter or ourselves. And what really would probably be the most helpful thing is to take pictures of it to try and help us, you know, identify what the best solution to that problem would be.
Right.
Thank you.
Yeah.
Absolutely.
So that looks to.
So that's the end of So that's the end of our questions on the chat. Is there anything else that anybody wants to bring up, or any other questions that there might be?
Can I ask one more quick question?
Absolutely.
One of the biggest, like, an issue we have with, like, the Polara Navigator buttons is in City of Tampa, a lot of our mainline intersections, we keep our main line on recall. So it's not pedestrian activated. It just comes up with the green.
Right.
And I know their buttons, you know, like yours, they active the voice wait comes up when the button is pressed. But if I put the intersection of recall, will the button automatically say wait for, you know, like visually impaired, or is that only when the button is pressed?
Good question. So we actually do have that capability here. We do have what's called the recall setting right here. If you're looking at our screen on our Pet Connects, we do have a recall setting. So what happens is every single time after the walk phase goes down and it goes back into don't walk, it will save that wait message. You can also do an acknowledgement repeat time right here. So it'll repeat that message once every 3 seconds, once every 5 seconds until the next walk cycle. So we do have a recall setting. Nobody has to press a button. It'll just automatically play that wait message as soon as it goes into a flash don't walk. Oh, I'm sorry, don't walk.
Thank you very much.
Yeah, absolutely.
No Any other questions? It does not sound like it. So thank you, Pete, for helping us set this up. We're really happy that we were able to present this to you all. And as we said earlier, we will be sending Pete a copy of this PowerPoint, this presentation, and I'm sure he'll be more than happy to send it out to you. He might send it out to you even if you don't ask for it. But please, if you do have any questions, contact Pete, contact us, visit our website. You can go to pedsafety.com for a list of all of our products, all of the different things that we have going on. And, you can follow us on Twitter, LinkedIn, Facebook, and, kind of stay up to date with what we are doing. So with that, thank you all. And we look forward to working with you.
Awesome. Thanks again.
Absolutely. Thank you very much. Thanks again, Pete.
Thanks, guys.
Absolutely.